When the dinosaurs vanished, was it just Earth's bad luck or a cosmic inevitability? We all know the asteroid story, but what if that catastrophic moment was just one act in a much larger, universal play about planetary collapse? For 66 million years, a terrifying question has been buried beneath the dust of their extinction. Was it unique, or an inevitable pattern whispered across the cosmos? Today, we're diving into the thriving world of the late Cretaceous dinosaurs, their lives, hunts, and diversity, before exploring the cataclysm that ended it all. And we'll ask the chilling question, could this be a glimpse into humanity's distant future? Stick around, because this isn't just ancient history, it might be a warning. Let's travel back 66 million years to the end of the Cretaceous period, a time when dinosaurs ruled a lush, warm Earth. But their reign ended abruptly in one of the most famous mass extinctions ever. What if the asteroid that wiped them out wasn't a freak accident, but part of a recurring cosmic script? Super eruptions, global fires, atmospheric chaos. These aren't one-offs. They're patterns that have played out before and could again. Let's start by meeting the dinosaurs in their prime. Imagine a planet teeming with life. The late Cretaceous was warmer than today, with higher sea levels creating vast inland seas. Forests of ferns, cycads, and the newly evolving flowering plants stretched across continents that were drifting apart. No ice caps at the poles, a greenhouse world perfect for giants. Dinosaurs had dominated for over 150 million years, evolving into an incredible variety. Let's break down some key types. First, the carnivores, the hunters. The iconic Tyrannosaurus rex, or T-Rex, was one of the largest land predators ever. Up to 40 feet long, with bone-crushing jaws delivering 12,000 pounds of bite force, T-Rex likely ambushed prey or scavenged. It lived in what is now western North America, roaming floodplains. Smaller but deadlier in packs, Velociraptor, feathered, turkey-sized theropods with sickle claws. They hunted in groups, taking down larger prey like Protoceratops in the deserts of Mongolia. Now the herbivores. Triceratops, massive three-horned beasts weighing up to 12 tons. They lived in herds, browsing on low plants in North America, using their frills and horns for defense against predators. Duck-billed hadrosaurs like Edmontosaurus formed huge herds, migrating across landscapes. Titanosaurs, the largest land animals ever, like Argentinosaurus, over 100 feet long, lumbered through South America. Lifestyle? Many were social. Evidence from bone beds shows herding in Triceratops and hadrosaurs. Carnivores like T-Rex may have been solitary ambush hunters, while raptors possibly coordinated attacks. Nests and eggs reveal parental care in some species. Birds, feathered dinosaurs, were already diversifying, and small mammals scurried in the undergrowth. This was a balanced ecosystem, with apex predators keeping herbivore populations in check and plants fueling it all. But beneath the surface, trouble was brewing. For hundreds of thousands of years before the end, massive volcanic eruptions in what's now India, the Deccan traps, poured out lava, covering 500,000 square kilometers. These flood basalts released huge amounts of CO2 and sulfur gases, causing acid rain, warming, and toxic skies. Some scientists argue this stressed ecosystems, weakening species. Then, the knockout punch. A 10 to 15 kilometer asteroid slammed into the Yucatan Peninsula, creating the Chicxulub crater. The impact vaporized rock, triggering earthquakes, tsunamis, and wildfires worldwide. Dust and soot blocked the sun for years. An impact winter. Photosynthesis collapsed. Food chains crumbled. In the aftermath, dead forests, acidified oceans, mass die-offs. Non-avian dinosaurs perished, along with pterosaurs, mosasaurs, and 75% of species. Survivors? Small burrowing mammals, birds, crocodiles, adaptable generalists. The dinosaur extinction, the Cretaceous Paleogene, or KPG event, is one of 5 Big Five mass extinctions. But look closer, patterns emerge. The worst? The Permian Triassic Great Dying, 252 million years ago, caused by Siberian traps volcanism. CO2 spiked, oceans acidified and lost oxygen. 96% of marine species gone. Like Deccan plus Chicxulub, but volcanism alone nearly ended life. Other extinctions involved volcanism, End-Triassic, impacts, possibly others, or climate shifts. Asteroids hit frequently, small ones daily, Chicxulub-sized every few 100 million years. Large igneous provinces recur too. These aren't isolated. Rapid carbon release from volcanoes or impacts disrupts climate, oceans, food webs. Global fires, acid rain, cooling, then warming. It's a script. Overload the atmosphere, collapse ecosystems. So, is the dinosaurs' end a dress rehearsal for us? Asteroids. We track them now. Chicxulub-level impacts are rare, one every 100 to 500 million years. But we're preparing deflection tech. Volcanism. Supervolcanoes like Yellowstone erupt every 600,000 years, devastating regionally, but not extinction level alone. The real parallel? Rapid climate disruption. Today, human emissions mimic volcanic carbon release, warming, acidification, biodiversity loss. We're in the 6th mass extinction, driven by us. Dinosaurs didn't see it coming. We do. Their story warns, planets have limits. Ignore recurring cosmic and geological forces, or self-inflicted ones, and even dominant species fall. But we have knowledge, technology. We can change the script. What do you think? Was the asteroid a one-off, or part of a universal pattern? Could humanity face a similar fate? Drop your thoughts in the comments. If you enjoyed the video, hit the like button and subscribe for more deep dives into Earth's epic history. Thanks for watching. See you next time.